All right. Hello, everybody. Happy Tuesday. I told you that I wasn't going to be here, and surprise, I'm not here. We talked about this yesterday, but we're going to have a video. Hopefully, by now, you have had some time to go ahead and work on your do now. We're going to go over just a few of these, looking at just some things we need to remember for today, and just making sure that we remember our concepts from yesterday. So, taking a look at this do now, let's start with number one. Biggest thing with number one, and again, we've seen this before, we've talked about this before, we want to make sure that this 2 on the outside, right, that power on the outside of the parentheses, need to be distributed to all 4 of these terms. They've got to go to all 4 of those. And so, not only are we distributing this 2 to the variables, but to the 2/3 as well. And so if we write this out, we're going to have 2/3 squared times x to the 4th, I'm going to write this all out, squared times y cubed squared times z to the 5th, there it is, squared. And so this 2 here with 2/3 means it's going to be 2/3 times 2/3. And so this is 2/3 times 2/3 times x to the, well, we have a power to a power, so 4 times 2 times y to the 3 times 2 times z to the 5 times 2. From here, remember that when we multiply fractions, we just multiply left to right, and so I'm going to have 4/9 times x to the 8 times y to the 6th times z to the 10th. And this is our final answer. All right, we're actually going to skip number 2. I'm going to wait until I'm there in person to be able to talk about number 2, just because it's really involved. And if you've noticed, my pen doesn't like writing really small, and so for now we're just going to skip it. But we are going to tackle 3, 4, and 5. Hopefully these were easier. I really just want these to be kind of quick hits, taking a look at these. If we look in 3, we have t to the 5th times t to the -2nd. This is the multiplication of like bases, which means that we're going to have to add these exponents. And so I'm going to have 5 plus a -2. Go ahead and put that in parentheses. Which means that we're going to have t to the, well, 5 plus a -2 is just 3. T cubed. On number 4, this is what we talked about yesterday. We have the division of like bases. And so as we talked about, the division of like bases is actually going to be subtraction of our exponents, specifically our numerator minus our denominator. And so we're going to have x to the 8 minus 2, which is going to be x to the 6th. And lastly, over here, number 5, we saw this already in number 1. We have a power raised to a power. When we have that, we multiply those exponents. And so it's going to be x to the 4 times 2. It's going to give us x to the 8th. All right. Go ahead and pause the video if you need to get any of this down. But now we are going to take a look at this Explore. Now, we have some things in front of us. And so we're being told that Jason and Latoya are evaluating the expression 8 squared over 8 to the 5th. Their work is outlined below. As you review their work, consider who do you agree with and why, and could both be correct. And so it's going to be your job to take about 3 minutes, review each person's work, and get down who do you agree with and why. 3 minutes silent and solo. Your time starts now. You can pause the video. All right, so you've had some time to think about this and sort of look at both approaches. And so the first thing I want to look at here is Jason's approach. Jason takes the standard approach of we take the numerator power, subtract the denominator power. That's what we talked about yesterday. And we know for a fact that given the quotients of power property, this is 100% correct. And so we know, yeah, Jason did it right. And so now let's take a look at Latoya. If we look, we have Latoya expanding this out, right? We've gone from 8 squared over 8 to the 5th, and Latoya says, okay, well, it's actually 8 times 8 over 8 times 8 times 8 times 8 times 8. And so it then goes, oh, I have the same thing over the same thing, so I can actually cancel these. And so when we cancel these, we're actually going to have, right, the one step that she doesn't really write is 1 over 8 times 8 times 8. What she says is, well, it's really 1 over 8 cubed, because we have 8 times 8 times 8. And so hopefully while we were looking at this, this is admittedly not the way that we have talked about doing it, but if you look, Latoya doesn't actually make any math errors. And so when we see this, we should actually hopefully say, oh, yeah, Latoya's work is actually correct. And so then it begs the question, okay, well, what does that mean about 8 to the negative 3 and 1 over 8 to the 3? Well, if these are both correct, then it means that these are going to have to, by definition, right, be equal to each other. And so I'm going to have 8 to the negative 3 is equal to 1 over 8 to the third. And so in our little blurb here, what I want us to stamp is that both are correct. Which means that, I'm going to repeat that same thing, 8 to the negative 3 is equal to 1 over 8 cubed. Go ahead and pause the video if you need to get this down. But once we come back, we are going to go ahead and take out our notebooks, open up to your table of contents, and again, if you need to pause, go ahead and pause. Alrighty, so today we are going to look at actually two special properties. The first one is going to be something we just saw, and the second one is hopefully going to be an addition that's really easy and quick and pretty satisfying, actually. And so today we are adding 5, because we're in unit 5.04, and we are doing negative and 0 powers. Today is 2/13. And so, as we just saw in that Explore, we haven't really talked about what happens with the negative power. In fact, you've heard me say multiple times, hey, we're just going to leave it like this, we're just going to leave it like this, we're going to talk about it. Well, guess what? We're finally talking about it. And so, we're going to start with the negative power. And so, negative powers say the following. If we have x raised to the negative a could be any number, and quite frankly, x could be any value. If we have x raised to the negative a, what we do with this is we end up making this a fraction with this in the denominator with a positive power. A positive power. And so in English, normally we start with a stamp, but with this one, it's going to be easier to kind of talk about it after the fact, after we see it. And so in English, what's really happening here is we make our base the denominator with the same positive, I'll underline this, power its numerator is 1. And so anytime we see this, we essentially take the inverse. And so when we see it like this, again, think inverse, right? We're going to put that in parentheses down here. Think inverse. Should be yelling at us. And so, we make our base the denominator with the positive power. Its numerator is 1. And so let's take a look at an example. And so if we're thinking about example 1, let's take, what number can we use? Let's take 2 to the negative 2. The first thing I'm going to do is know that that base now needs to become the denominator of a fraction that has a numerator of 1. And so I'm going to have 1 over 2, and now I make my power positive. So 2 squared. Well, 2 squared is going to be 1 over 4. And so 2 to the negative second is equal to 1 over 4. Something I don't want to see and something we got to be really, really, really careful of. We're going to star this. Negative exponents do not change the sign of the base. At no point should I see that 1/4 is negative. That's not what the negative exponent means. It simply means change it into the fraction, so take its reciprocal, take its inverse, and then apply the positive power. So again, 2 to the negative 2 is really 1 over 2 squared, which is going to be 1 over 4. Let's check out another example. Example 2. Well, let's take y to the negative 3rd. Now, again, y is just a variable, and so I'm going to end up just leaving the power on it, but I have to change this, and so I'm going to have 1 over y to the positive 3rd. So again, taking that inverse, taking that reciprocal, simply flipping it. Now, this example, or this is going to come up, and so I also want us to be really comfortable with this. We're going to look at example 3. Now, example 3 is going to say we have 1 over x to the negative 2. Now, again, the kind of quick way to think about this, and we can get into more detail when I come back on Wednesday, but the quick way to think about this is, again, when we take the inverse, when we take the reciprocal, this is essentially just going to flip. That's what's going to happen. Wherever this is, it's going to change positions. And so if it's starting in the denominator, it's actually going to jump up to the numerator. And so this is going to turn into x over 1. And again, I make my power positive. And so I'm going to end up with just x squared. And so again, over here, we're just going to make another note. I know this one has a lot of notes, kind of more so than the other ones, but we need to be super clear because negative exponents start to do some really different things from what we've seen before. And so the note that we want to make is that if the base of the negative exponent is in the denominator, it moves to the numerator. So if the base of the negative exponent is in the denominator, it moves to the numerator. Again, simple way of thinking of this truly is wherever it is in the fraction, it swaps. It just swaps, right? If we think of like keep, change, flip, it's just the flip part of it. That's all this is really doing. And so we're going to now take a look at that second property, because if you look at the header, we have negative and 0 powers. And so the nice thing is that the 0 power is way less complicated than the negative power. And so if we talk about the 0 power, the 0 power actually says anything raised to the 0 power is 1. That's all it is. And so I could have, right? Or well, if we think of the general form of this is going to be x to the 0 equals 1. Simple as that. Now, if we think of, I'm going to put 2 examples. I'm going to sort of run out of room here, but just go ahead and put them vertically in your notebook. Example 1, I could have 3x squared plus 4 all raised to the 0 power 1. That's 1, right? I could have a bunch of things going on, and as long as the exponent there is 0, it's 1. And so let's look at example 2. The piece I have to be careful of with the 0 power is that only what's being raised to the 0 is 1. And so if we have other things going on, for example, if I had 4 to the 0 plus 2x to the 0, this here is deceptively tricky. This first piece, 4 raised to 0, that's 1. That's 100% 1. But then I have plus, and I'm actually going to break this out into 2 steps. 2 times x to the 0. I'm doing this again so that we have a good visual separation that the only thing actually being raised to the 0 in that second term is the x. That 0 is not applied to the 2 at all. And so I'm going to have 1 plus 2 times 1. Okay, well 2 times 1, that's just 2. And so 1 plus 2 is 3. And so even though we have a bunch of zeros, or a bunch of powers being raised, a bunch of bases being raised to 0 here, we have to be careful. And only the things being raised to the 0 are 1. If we think about this first example, this entire expression was raised to the 0, which is why we could say, well, yeah, that's just going to be 1. All right, I'm going to scroll back up. Go ahead, get down anything you need to get down, and pause the video here if needed. All right, so hopefully you've got all that. And so now we're going to take a look at problem set A, as we usually do. In problem set A, I would like you to please work on 1, 2, 3, and then we're going to come down and we're going to go 1, 2, and 4. So again, 1, 2, 3, 1, 2, 4. Work on those silent and solo. You're going to have, I'll say about 6 minutes to go ahead and work on that. Your time starts now. You can pause the video here. All right, so you've had time to work on these, and hopefully these first 3 were a little bit more simple than some of the others. For these first 3, some lovely technical problems. There we go. Just getting rid of that circle. Let's take a look at number 1. So x to the negative 7th. There's nothing tricky going on. This is pretty straightforward. We're simply going to take this, think of the inverse, think of flipping it, think of the reciprocal. Again, we have so many ways to talk about this, but I'm going to have 1 over x to the positive 7th. Things to make sure: that 7 should be positive. At no point should our base be negative. Positive base, positive exponent. Taking a look at number 2. Now, on number 2, again, we're starting in the denominator, and so this is very similar to that example that we saw and then the note that we made. And so when we start in the denominator, it simply means that we're going to take this and move it to the numerator. And so I'm going to have x over 1, right? Flip that fraction to the positive 3rd. And so that's simply going to be x to the 3rd. Now, looking at number 3. Number 3 is purposefully tricky. And I say that because, again, we want to be really careful here of what actually has an exponent applied to it. And so I'm going to say that this is actually 5 to the x minus 2. Again, creating that visual separation that this negative 2 has nothing to do with this 5. It is not being applied to the 5. Truly, the 5 is just sort of along for the ride at this point. And so this is going to be 5 times 1 over x squared. From here, I do want us to clean this up with one more step, right? This is really 5 over 1. And so last step we're going to have is simply making this back into one fraction. And we're going to have 5 over x squared. And so if I have 5x to the negative 2, I really have 5 over x squared. All right, moving down to a few of these other ones. 6 to the negative 2. Well, again, pretty straightforward. It's just 1 over 6 squared, which is going to give us 1 over 36. Make sure that when we have a number that's easily squarable, we're actually just doing the math on that square. Don't leave that as 1 over 6 squared. Number 2, again, same thing as number 3 up above. This is really negative 3 times x to the negative 5th. Don't get confused or don't get tricked by the fact that this negative 5 is not on this 3. And so this is going to be negative 3 times 1 over x to the positive 5th. Again, positive base, positive exponent when we apply this rule. And so now, cleaning this up, negative 3 over x to the 5th. Notice that this negative happens because this 3 starts as a negative. And now, taking a look at 4. Now, on number 4, the big thing we actually just need to be careful of is there's actually a few rules going on here at once. And so what we're going to learn is that we can do them really in any order that we want. I can either perform what's going on in the parentheses first, or I can apply this power first. It's going to be up to you. And so I'm going to opt here for actually doing what's in the parentheses first, right? If we think of GEMDAS, we're going to do that grouping first. And so I'm going to have n to the 8 minus 10 cubed, which is going to be n to the negative 2 cubed, which is n to the negative 2 times 3, which is going to give us n to the negative 6. Applying now that new negative power property, that's going to be 1 over n to the positive 6th. All right, once again, I'm going to scroll back up. Go ahead and just get down anything you need to, and you can pause the video if necessary. All right, from here, we're actually going to jump to problem set B. Now, inside of problem set B, we are going to work on 1, 3, 4, and let's see what else will help us out for our exit ticket. And 5. And so 1, 3, 4, and 5, only 4 problems. Again, you're going to have 6 minutes. Please work silent and solo. Your time starts now. Go ahead and pause the video. All right, so by now you've had some time to work on these. We're going to just rush through a few of these because, again, zero property is so nice and so, quite frankly, not complicated. And so on number 1, 3 raised to the 0 power, 1. Simple as that. On 3, now this is more like example 2 on the 0 power. This first piece is 100% 1, but we still have that minus 4. And so 1 minus 4, negative 3. Over here on number 4, we have a whole lot going on, but everything that's happening here is all being raised to the 0. And so I can actually just say, well, because what's going on in here is just raised to the 0, it's just 1, right? This is similar to that first example in that 0 power property. This is just 1. And so now let's take a look at 5. 5 is a little bit more involved. That's okay. 5, we got to do some other things first. And so I have x to the 3rd to the 4th. So I really have x to the 3 times 4. And then I have x squared times x over 2. Now, be careful. This is the multiplication of like bases, which means I need to add the powers. So this is really x to the 6 plus 2. And so I'm going to have x to the 12th over x to the 8th, which is going to give us x to the 12 minus 8, which is going to be x to the 4th. X to the 4th. All right, once again, go ahead and pause if you need to get anything down. We are moving to our exit ticket. It is officially that time. Now, on number 1, use everything we've talked about, including, honestly, even that first problem in our do now. Use everything we talked about. Do not get tricked. And then number 2, I'm going to tell you right now, there is more than one correct answer. When they say which of the following is equivalent, there is more than one. You're going to have until the end of class to work on this silent and solo. I will be looking at these when I get back. This is their 2 really important properties that we have to know. If you finish and still haven't handed in your homework, work on your homework when you are done on this. Again, you have until the end of class, silent and solo, and I will see you all tomorrow. Have a wonderful day.